I'm not sure what happens with the EMI, but let me continue. So supplement one, we have a single variable to a function. I mean single variable to define a function. And this time, we have two functions. So we may have the newly defined function, z and w. So you can have function for z. Furthermore, you can have a different function. So that's why two variables to have two functions. So that says we need to have the join PDF. As for join PDF, how to do? This time we don't have a formula directly. Well, still we can have a CDF first. So we need to perform partial differentiation. This time it's partial differentiation. Right? So you need to have a region properly. Well, so first of all, they try to ask you to have the region, but I skip the description. I just jump to the proper one to have the result. So you still can perform CDF first, and then you can have a differentiation to find PDF. But I jump this. I don't have the formula directly. To have the formula, you need to go through the slides here. And so that we have a change of variables. To have a change of variables, then we may have some further results, including Jacobian. Right, including we need to use Jacobian. And what to do, we may have a lot of description. So I skip all the details. A lot of description, then summarize, we have some ideas like this. In chapter 2, in supplement 1, actually we can have this. Fy, right? It should be summation of x. And here we have dx dy, but we need to tag absolute value. So here we may have xi and xi. So this is a formula, remember? This one, supplement 1. And supplement 2 here, almost the same. Supplement 3 here, almost the same, but this time it's ZW and XY. And here we have dx dy and dz dw. So almost the same. However, almost the same, we need to have a Jacobian. So we have the new formula. ZW, and then we have summation, all right, for all of x and y. So xi, yi, and here summarize the same. D, but we use partial, not d. Xi, yi, and the partial z and w. And so we still have the same idea. Move this partial z and w to the left-hand side. Summarize, we have the probability, right? Probability observed in terms of z and w. It should be equal to the probability summation of all the possible probabilities. Well, I still forget one thing. We should have absolute value sign again. So similar to this one. This time we have two variables. So two variables still partial, something like dxi, d or yi over dz, dw. Alright, but this time I have the new notation, partial for the two variables, partial for the two variables. So actually it should be the third variable perform partial differentiation with respect to z and with respect to w. I skip all the details, but I already have the formulas around. And the formula here, we need to have the further details about the final one. The final one relating to Jacobians. So Jacobians here. So we skip all of the details. We have the Jacobian, this one. Jacobian actually is the determinant. And previously we have x. I have xi, xi, and yi. So this is a Jacobian. Previously I already have xi, yi, and we have z and w. All right, but I have the similar notation. So Jacobian here, in fact, you have the determinant. Get xi perform partial differentiation with respect to z, w. Yi perform partial differentiation with respect to z and w. So this is the form, and this form we call Jacobian. Also Jacobian zw or Jacobian xi, don't memorize that one. Just use a ratio. Xi and yi perform Jacobian, then xi and yi perform differentiation with respect to z and w, but arrange it in a determinant. But finally, don't forget we need to have the positive value, so we need to have the absolute value for the determinant of this one. So finally, we should have absolute value, absolute value. That's it. So for supplement 3, in fact, I introduced a formula. I skip all the details about the derivation. I just let you know the formula. So the formula, maybe you can think about from 1-to-1 mapping to current 1, 2-to-2 mapping. And almost the same, but we have the introduction of Jacobian to the current derivation. Well, that's it. So something like this. We have the formula. Supplement 1 formula to the current formula. The current formula we have for this. And this idea almost the same. So this is formula 1 for 1-to-1 mapping. And right now we want to have a 2-to-2 mapping. But we have the new formula. And the new formula needs to utilize Jacobians. Alright. If we have Jacobians, then we have this to illustrate how to have Jacobian and tag in the absolute value sign. Well, that's it. So up now we have this formula for 2-to-2 mapping. And of course, I allow you to think about this for 3 minutes. Alright, so if you have any questions, just talk to the members. Okay, that's it. Discuss right now. Okay, so that's it. We have the formula because we want to apply the formula to have further derivation. Even I may jump to the proper position to talk about further. So finally, we have the formula. I don't know Jacobian, right? ZW. So we will have a Jacobian ZW, and we have this. So finally, we have the formula. PDF of Z and W. PDF of X and Y, and then multiply Jacobian. And Jacobian, should we use ZW here? In fact, don't memorize the ZW, just have Jacobian. As for how to have a Jacobian, I use this way. X, Y, because X, Y here. And partial differentiation with respect to ZW. And this way, it will be easier to directly have a Jacobian. So if so, we will have a Jacobian. Sorry, SI and SI, YI. All right, but don't forget we have an absolute value sign. So finally, we will have an absolute value sign problem. Well, up now, I ask you to know we have the formula. And later, we will apply the formula to have the variations. For example, this one. But right now, we don't emphasize this one. I jump to the next example.